Good morning po. Good afternoon na pala. Sino? Miss Catherine. Miss Catherine. Catherine. Miss Catherine. Mendoza. Hello po. Sino po? Yes. Catherine, may pwede pong mag-record ng ano po, ng ating pong meeting. Kasi naka-data po ulit ako. Baka po may malikdangan din po ako. At meron din po kaming, mag-multitasking po ako. Meron din po kaming a-attendan na seminar. Yan, multitasking po tayo ngayon. Sino pong pwede pong pero ako po ay join po sa cellphone. Sino po ang pwede pong mag-record ng ating pong meeting? Anyone po na pwede pong mag-record? Makikiraise hand na lang po. Sino pong pwede? Hello po. Hello? Ay, ikaw na lang, Ineng, Priscilaan.
Sige po, ma'am.
Okay, so salamat po. So, anong natapos po natin ng last meeting? Bali, dalawa na po yung nakapag-present? Or hindi
Yes
pa po? Okay. So, makiki-ready po ako ng group po ng polymers. Ano po? Para po sa presentations. Medyo kaunti pa po yung naandito. Medyo padamihin natin ng kaunti po para before po mag-start. Paki-ready na po ng group po ng polymers.
Ma'am, magpe-present na po ako.
Wait lang natin ng kaunti yung iba ha. Pero pwede ka na mag-present. Pero ang start po ay mga 1 minute pa po. Baka madadagdagan kayo. Makiki-start na po ang grupo ng followers. May ilalaki pa po yan. Pero maliit po.
Okay na po, ma'am.
Okay na po. Salamat. Okay na po. Thank you po.
Ayan, audible po ba?
Yes po.
Ayan po. So, everyone, so of our module is the polymers. So, next slide po. So, yan. So, first, we're going to discuss po which yung ating intended learning outcomes. So, after studying this able to do in terms of its chain structure, and in addition, how the molecules may be generated from repeat units. The second one is name and briefly describe the four general types of polymer molecular structures, the three types of stereoisomers, and the two kinds of geometrical isomers. And lastly, the four types of copolymers. Number three is cite the differences in behavior and molecular structure for thermoplastic and thermosetting polymers. Next slide po. Nagcha-choppy-choppy po ba? Mahina lang daw po yung net ko.
Okay naman po sa akin. Hindi naman siya topic.
Sige po. Sige po. Thank you po. And the fourth one is discuss the different types of polymers and its uses. And lastly, differentiate the different forming techniques in plastic. Next slide po ulit. So let's start with polymers. So naturally occurring polymers, those derived from plants and animals, have been used for many centuries. These materials are cotton, wool, leather, and silk. So other natural polymers such as proteins, enzymes, starch, and cellulose are important biological and physiological processes in plants and animals. Next slide po. So modern scientific research tools have have made possible the determination of the molecular structures of this group of materials and the development of numerous polymers that are synthesized from small organic molecules. Many of our useful plastics, rubbers, and fiber materials are next po ulit. In fact, since the conclusion of World War II, the field of materials has been virtually revolutionized by the advent of synthetic polymers. The synthetics can be produced inexpensively, and their properties may be managed to the degree that many are superior to their. In some applications, metal and wood parts have been replaced by plastic, which have satisfactory properties and can be produced at a lower cost. So, in short po, yung polymers is a substance that has a molecular structure consisting chiefly or entirely of a large number of similar units. So yun, many synthetic organics materials used as plastic and resins. So yung word polymer daw is derived from a Greek word polymeros. So polus means many and meros means unit. Thus, the word polymer daw means many unit. So a polymer is a large molecule made up of smaller, joined together molecules. Polymers. One way of thinking about polymers daw is like a chain of connected up paper clips. Yung some examples daw ng polymers ay yun nga nabanggit ko kanina which are yung silk, wool, DNA, cellulose, and proteins. So next slide po. And hydrocarbon molecules. Next slide po ulit. We have here. So first, many organic materials are hydrocarbons. That is, they are composed of hydrogen and carbon. Ayun, from the word itself naman, hydrocarbon of hydrogen and carbon. Next slide po. Unsaturated. Molecules that have double and triple covalent bonds are termed unsaturated. That is, each carbon atom is not bonded to the maximum for other atoms. Therefore, it is possible for another atom or group of atoms to become attached to the original molecules. So, yung unsaturated cover po. Excuse me. Next slide. Bonds are single ones and no new atoms may be joined without the removal of others that are already bonded. Pasensya na po, medyo mahina lang po talaga yung internet connection po namin dito. Kaya baka po nagpuputol-putol or naglalag po ako. Pasensya na po. Ayan, next slide po ulit. Ayan, some of the simple hydrocarbons belong to the paraffin family. Paraffin molecules include yung methane, ethane, propane, and butane. So the covalent bonds in each molecule are strong, but only weak hydrogen and van der Waals bonds exist between molecules, and thus these hydrocarbons have relatively low melting and boiling points. However, boiling temperatures rise with increasing molecular weight. Next slide. Hydrocarbon compounds with the same composition may have different atomic arrangements, a phenomenon merism. For example, ay nasa taas po, whereas a molecule of isobutane is represented as follows. As you can see naman po, tulad nga po ng sinabi dyan, na same composition sila pero they have different atomic arrangements po. Then next slide po. There are also numerous other, many of which are involved in polymer structures. So a few examples are alcohols, ethers, hydrocarbons. Next slide po. And polymer molecules. So the molecules in polymers are gigantic in comparison to the hydrocarbon molecules already discussed. Because of their size, they are often macromolecules. Within each molecule, the atoms are bound together by so ayan, polymer molecules from which polymers are synthesized are called monomers. Next slide po. Repeat units. These long molecules are composed of structural entities which are successively repeated along the chain. So a repeat unit or repeating unit is a part of a polymer produce the complete tulad nung sa example is beads of a necklace. So next slide po. Monomer refers to the small molecule from which a polymer is synthesized. Hence, monomer and repeat unit mean different things, but sometimes the term monomer or monomer unit is used instead of the more proper small molecules that bond. And nakalagay dyan na monomer and repeat unit mean different things. So, ang difference kasi ng monomer or at repeat unit is that monomers are the small molecules that are joined together to form a polymer. While yung repeat unit naman is yung basic structural unit ng isang polymer and they are formed by the chemical bonding or two or more monomers. Isa pa ay yung monomers are the starting materials for polymer synthesis, while yung repeat units naman yung building blocks ng polymer chain. Yung monomer typically small, simple molecules, while yung repeat units naman can be more complex and can contain multiple functional groups. Ayan lang po. So, next na po.
So for my presentation naman po is the chemistry of polymer molecules. So starting with homopolymer. So from the word homo or homo, sa Greek ang meaning kasi nito is the same. So when all of the repeating units along a chain are of the same type, so makikita mo natin mamaya yung illustration, but ang pinaka madaling example para magets natin is parang yung Lego block na pare-parehas yung sizes nila. Imagine na lang din natin na parehas yung kulay nila. So next is copolymer. Change chain may be composed of two or more different repeat units. So, dito naman makikita natin na yung example ulit is Lego block pero magkakaiba na sila ng width. Parang makikita na natin yung isang block by 3s, yung isa by 2s, tapos yung isa naman ay by 1. So, ito yung illustration ng homopolymer at saka yung copolymers. So, kita naman natin na pare-parehas talaga yung sa nasa taas tapos meron differences ng size pati na rin dun sa color. So, sa functionality naman, since dun kasi sa homopolymer, pati dun sa copolymer, ang iniintindi talaga dun is yung composition lang. So, kung two or more or mas marami, yun lang talaga yun. Pero dito naman sa functionality, iintindihin natin yung structure niya mismo. So, is the number of bonds that a given monomer can form. That is by functional monomers, a two-dimensional chain-like molecular structure. So, para siyang Lego na ginagawa na mismo. Unlike yung kanina, parang ang iniintindi lang natin is kung ilan yung Lego block. Dito naman is paano sila kinoconnect. So, yung from dun sa taas, kinoconnect lang siya from sa baba. So, meanwhile, dito sa trifunctional monomers, have three active bonds from which a three-dimensional molecular network structure results. So, katulad ng puzzle. So, wala namang puzzle na parang Lego lang na isang way lang yung pag-connect nila. Sa puzzle, merong tatlo yung nakalawit, meron naman yung tatlo din yung butas or minsan dalawa. So, ganun yung trifunctional monomers. So, ito yung repeat units for the 10 most common polymetric materials. So, para ma-explain natin, yung polythylene or yung nakikita natin dun sa pinakataas, yung HCH. So, ang basa dyan is CH2 tas CH2. So, ganun yung pagbasa ng repeat units. So, next, ito yung latter part nung sa top 10. And then, next is the molecular structures. Dito naman, magdidito tayo sa linear polymers. The repeat units are joined together end-to-end in single chains. These long chains are flexible and may be thought as a mass of spaghetti. So, imagine nyo na lang may paper clip kayo. Tapos, i-connecta nyo siya parehas. So, hindi lang siya yung dalawa lang. So, bale, endless chain ng paper clips. Parang ganun yung linear polymers. Pare-parehas lang sila talaga. And next is branch polymers. Polymers may be synthesized in which side branches or chains are connected to the main branch polymers one. So, mamaya makikita nyo kasi meron ding illustration mismo nung para sa linear pati sa branch kung ano talaga yung main differences nila. Pero may isip talaga natin na para siyang puno na yung isang polymer connected na mukha talagang branch. So, cross-linked polymers. Adjacent linear chains are joined one to another at various positions by covalent bonds. Cross-linking is achieved by either doing synthesis or by non-reversible chemical reaction. So, medyo mahirap kasi yung illustration ng cross-link. So, alam naman natin yung adjacent, narinig natin siya sa triangle. But yung pinaka-close na maiisip ko na example is like isang ball ng rubber band kung saan connected sila ng nakapatong. Tapos may mas malala pa dyan, which is yung network polymers. Multifunctional monomers forming three or more active covalent bonds makes three-dimensional network. So, parang na siyang gagamba. Or I mean, spider web. Yung itsura niya. So, ito yung illustration. So, dun sa letter A is yung linear. Tapos yung B, kita naman natin mukha siyang branch ng puno talaga. Tapos yung letter C is yung cross-link. And yung letter D na mukhang spiderweb is yung network. So for molecular configuration, dito didiscuss naman natin yung isomerism. So isomerism is also found in polymer molecules where different atomic configurations are possible for the same composition, two isomeric subclasses. So stereoisomerism and geometrical. So dito naman is yung stereo Stereoisomerism denotes the situation in which atoms are linked together in the same order, head to tail, but differ in their spatial arrangement. So, mamaya makikita niya rin na parang beads talaga siya. So, kaya may mga beads dyan. Para sa akin, mukha talaga siyang beads na colorful na may iba-iba silang pattern. May tatlo kasing pattern yung sa branch nito. So, yung isotactic configuration, kung saan all of the R groups are situated on the same side of the chain. So, mapapansin nyo dun sa figure na nasa kanan, yung RH, yun yung mahalaga dun eh. Yung RH, RH, tapos RH. Kung saan sunod-sunod talaga sila, hindi sila nag-alternate. Then, for the next one is the syntactical configuration kung saan yung R group are alternating sides of the chain. So, RH, hindi katulad kanina na RH, RH, dyan naman RH, tapos HR, tapos RH, HR. Then, for the last configuration is a tactic configuration. The R group are situated in random positioning. So, dito, wala na talaga siyang, hindi siya sa walang structure, kundi hindi na siya organized. So, RH, RH, or HR, so, in random na talaga siya. And for the next slide is geometrical isomerism, having a double bond between changed carbon atoms bonded to each of the carbon atoms. Participating in the double bond is a side group. So, transpolysoprene, or also called gutta-perca, has properties that are distinctly different from those of natural rubber as a result of this configurational alteration. So, fun fact lang din, ang ibig sabihin ng trans ay opposite side. So, yung cis naman is on this side. So, para magets natin, yung double bond is closer dun sa cis kasi on this side nga siya, as the name suggests. Tapos dun naman sa trans, mas malayo yung double bond since on the other side siya. So, konting recap lang dun sa molecular shape or dun sa na-discuss natin kanina. So, yung structure na nahahati dun sa linear, yung straight line, yung branch na parang puno, tapos cross-link na parang rubber band ball, and network na parang spider web. So, para dun naman sa state ay yung isomers at saka yung geometrical, kung saan yung isotactic or yung RH, RH, tapos yung syntactic, yung RH, HR, yung nag-alternate, at yung atactic, kung saan random na siya or wala nga siyang, hindi siya organized. And doon naman sa cis, ulitin ko lang, kung saan siya is on this side and sa trans naman on the opposite side. Yun lang po. For the next presenter na po.
Hello po, and ang akin naman po is the thermoplastic polymers. Basically, thermoplastic polymers have a lower molecular weight. It softens when heated and finally liquefies and hardens when cooled. This process is reversible and repeatable. Since thermoplastic materials have low melting temperatures and tensile strengths, they can be easily remolded and recycled. And ang thermoplastic polymers naman po used in materials used in making sports equipment, used in making toys, in automobile parts, in making CDs and DVDs, and also used din po siya to like shampoo bottles, drinking bottles, and food storage containers that are made up po in thermoplastic polymers. Next po. And I'm sorry. And this is the example of thermoplastic polymers. Um, Polyethylene, it is the most widely used plastic in the world, being made into products ranging from clear food wrap and shopping bags to detergents, bottles, and automobile fuel tanks. It can also be slit or spun into synthetic fibers or modified to take on the elastic properties of a rubber. And next naman po is the polystyrene. Polystyrene is everywhere. It's in expanded foam state. Polystyrene can be found in coolers, materials used in road constructions, and to package everything from computers to food. The most okay, the most common and recognizable form of polystyrene is called styrofoam. Yun nga po, ang sa polystyrene po, most commonly po ang ginagamit po ay yung use niya po is to create a styrofoam. And yung polyethylene terephthalate, a strong snip synthetic fiber and resin, and a member of polyester family of polymers. And next po is yung we all know as the PVC. PVC was synthesized in the year 1872 by German chemist Eugen Baumann. Later in the 20th century, PVC was commercially used by the Russian chemists. They found it difficult to process the rigid polymer and sometimes the entire process would go in vain. Next po. Next naman po ay thermosetting polymers. Melting point, tensile strength, and molecular weight were all high in thermosetting polymers. They can tolerate high temperatures and once hardened cannot be reformed or regenerated, even when heated. This has primary bonds between molecules and is held together by strong links. Ang kaibahan naman po ng thermosettings polymers sa thermoplastics ay yung thermoplastics nga po ay nare-reform and dito naman po ay hindi. Next po. And some examples po ng thermosetting polymers ay vulcanized rubber. Vulcanized rubber is any type of rubber that's been hardened though the use of heat and sulfur. It's made via a curing process in which the rubber's elastomers harden in response to heat and sulfur. Next naman po is polyester resins. Are a large family of synthetic organic polymers formed by a group of heterogeneous molecules for both chemical structures and property. And next po is yung sa epoxies. Epoxy is a type of polymer, a group of chemical compounds that consist of loud molecules with repeating subunits. The molecular structure of polymers give them their toughness and elasticity, making polymers ubiquitous in daily life. Next po. And next naman po is the copolymers. Copolymers pertains to a polymer that is made up of two or more monomer. Many commercially important polymers are copolymers. These also have different variety of shapes depending on how different monomer species are involved in the polymer chain. Andito nga po may apat po siyang the random copolymer, the alternating copolymer, the black copolymer, and the graph copolymer. Sa random po, ang two different units are randomly dispersed along the chain. Tapos dun sa alternating copolymer naman po, as the name itself, the two repeats units alternate chain positions. And then naman po sa black copolymer is one in which identical repeats units are clustered in blocks along the chain. And then naman po sa graph, may mga branches po siya. And side branches of one type may be grafted to polymer main chains that are composed of a different repeat unit. Next naman po is the polymer crystallinity. Crystal structures may be specified in terms of unit cells, which are often quite complex. Highly crystalline polymers are rigid, high melting, and less affected by solvent penetration. Crystallinity makes a polymer strong but also lowers their impact resistance. And may mga factor nga po na nakaka-affect po sa crystallinity. The one po is the chain branching, the cross-linking, the symmetry of repeating unit, and the molecular weight itself. Degree of crystallinity. The degree of crystallinity may range from completely amorphous to almost entirely up to about 95% crystalline. In contrast, metal specimens are mostly always entirely crystal, whereas many ceramics are either totally crystalline or totally non-crystal. Semi-crystalline polymers are, in a sense, analogous to two base metal alloys discussed previously. And it can be measured according to the percent of crystallinity and the density of a specimen times the density of the specimen minus the density of the total amorphous polymer over density of a specimen times the density of a perfectly crystalline polymer minus the density of a totally amorphous polymer times 100. Next na po. Viscoelastic deformation. Viscoelastic mechanical behavior, intermediate between totally elastic and totally viscous, is displayed by a number of polymeric materials. This behavior is characterized by a relaxation modulus, a time-dependent of modulus elasticity. The magnitude of the relaxation modulus is very sensitive to temperature. Glassy, leathery, rubbery, and viscous flow regions may be identified on a plot of logarithm of relaxation modulus versus temperature. The logarithm of relaxation modulus versus temperature behavior depends on molecular configuration, degree of crystallinity, presence of cross-linking, and so on. And the last one is the fracture of polymers. Fracture strengths of polymeric materials are low relative to those of metals and ceramics. Both brittle and ductile fracture modes are possible. Some thermoplastic materials experience a ductile to brittle transition with a lowering of temperature, an increase in strain rate, and an alteration of specimen thickness or geometry. In some thermoplastics, the crack formation process may be preceded by cases, a region of localized deformation, and microvoids. Creasing can lead to an increase in ductility and toughness of the materials.
So yun po, bilang continuation po sa discussion ni Loridel, the last part is all about deformation of semi-crystalline polymers. We all know naman po na meron dalawang distinction ng polymers which is crystalline and amorphous. The amorphous one is a section which is composed of not structured or medyo break, madaling ma-break na structure yung amorphous, while crystalline is hard enough to realign its structure into its hardest form. So technically, semi-crystalline is a composition of two of those two amorphous, semi-amorphous, and semi-crystalline. So semi-crystalline, sa madaling salita, ay meron siyang region, amorphous region, which is madaling mabreak. So technically, pag meron tensile force, hindi lang mo siya, lalo na ito ay nagpo-form ng spherulitic shape, which means radially from the center. Kapag hinila mo yung outside part, magre-realign siya and susunod yung mga structures papunta sa central part. Next po. The next one is the other topic po, which is all about factors that influences the mechanical properties of semi-crystalline polymer. Pero bago yun, let's define what is mechanical properties. The mechanical behavior of a material reflects its response or deformation in relation to an applied load or force. So malalaman po natin while mechanical behavior yung pinagpopokusan nung mga factors na yun when it comes to semi-crystalline polymers. The first one is the polymechanical behavior influenced by in-service and structural processing. So technically, kapag nililikot mo isang bagay, ganito na kasimple, marirestructure siya, magkakameron ng bagong form. The next one is higher temperature or lower strain rates, decrease tensile modulus and strength, enhancing ductility. Sa madaling salita, kapag nag-a-apply ka ng heat or application ng init, mas lalambot yung isang bagay. So magiging ductile siya, mapuporm siya in thin wires, while lower strain rates talks about kung gaano kahaba ang magiging form ng thin wires. Sa madaling salita, kapag hindi mo masyadong hinahatak, walang ma-apply na force, ganun lang kaiksi yun. Kapag mas hinahatak mo siya, mas malalenten yung size ng isang wires. Proceed po. Additional factors that impact overall mechanical properties is yung 1 to 9 na po yan. Proceed po. Iisa-isahin po natin yan. Next. The first one is all about molecular weight. Tensile modulus is relatively insensitive to molecular weight. However, tensile strength increases with increasing average molecular weight. So technically, katulad na sinabi ni Mr. Medrano kanina, may halin tulad natin ng molecules ng isang polymers into a Lego. Kasi po, hindi naman lahat ng particles ay magkaka-same size. Pero technically, pare-pareha sila ng particles sa yun. I mean, pare-pareha sila na ganong particles, specific particle, pero magkakaiba ng size. So madaling salita, molecular weight affects the mechanical behavior in a way na it doesn't affect the steeper. Kasi technically, like a Lego brick, kapag pinagsama-sama mo siya, mag-harden siya, but it doesn't mean na hindi siya may break. So it doesn't make it steeper, which talks about tensile modulus, but it doesn't make it stronger, which talks about tensile strength. Yun po. Next po. The next one is all about the degree of crystallinity. Sabi nga po natin kanina, crystallinity is a type of object which has a aligned or more compact structure. Sa madaling salita, degree of crystallinity is also the level of crystallinity, which is also talks about the hardness itself. Sa madaling salita, mas high yung crystallinity, mas more organized yung structure, mas mahirap siyang sirain ng isang applied or load force. Next po. Pre-deformation by drawing. Sa madaling salita, makita naman po natin yung prefix na pre, which means before, and deformation, which is pagkasira. So technically, pre-deformation by drawing is, ang sinasabi lang dyan is, bagong pa man likot mismo isang bagay is may procedure before na ginagawa yan. So mas mapapadali yung pag-restructure mo kasi may pre-process ka ng ginagawa. Kapag yung sa pre-process na yun is na-realign mo ng structure. So technically, it helps yung next procedure yung gagawin mo para mas mapadali yung pagkagulo or pag-realign ng structure on the object itself. Yun lang po. Next. Heat treating. Heat treating in the context of polymers means exposing the material to heat. Sa madaling salita lang po, heat treating is the application of heat. Kapag may high temperature, magkakameron ng melting, which is nagkakos sa isang object, solid object, na mag-turn into its liquid phase. Magkakameron ng cool down. Alam na po natin na in thermodynamics, energy in is equals to energy out. So technically, pag nag-apply ka doon ng heat with factor na nanggagaling sa paligid, technically, magre-reduce yung heat na yun. Magkakameron tinatawag ng cool down. Pag nag-cool down ng isang bagay, mas lumalamig siya. Once na lumalamig, ang isang polymer, magkakameron ng tinatawag na better mold. Sa madaling salita, magre-reform siya. Ilan po. Next. Deformation of elastomers. Para mas madaling maintindihan, elasto means elastic siya. Elastomers is equivalent to elastic polymers. Alam naman po natin na elastomer has a long, flexible chains of molecules. So technically, naipaliwanag na po ito mga grupo, pero repeat ko lang po, mas mahaba yung chains of molecules, ibig sabihin, mas rubber siya. Sa madaling salita, kapag elastomers ay mayroong long chain, kapag hinatak mo siya, mas mahaba yung chain. Pag nirelease mo yung spores, mas rubber yung pagbalik niya. Mas magbabak siya into original arrangement. Kasi po, kapag mas maliit yung chain of molecules, technically, it is fragile. Next po. Vulcanization, para mas madaling matandaan, vulcan. Anong nilalabas ng vulcan? Sulfur. Ito pong vulcanization is quite relevant to the topic all about heat treating. Sa madaling salita, there's also an application of heat. But ang kinaibahan niya, since it's vulcanization, there's an application of tinatawag nating element na sulfur, which is that sulfur bonds with the adjacent polymer backbone. Sabi ko nga din po kanina, mas paghaba ng isang chain of molecules, mas rubbery siya. Since sa vulcanization, hindi lang natin basta ina-apply ng heat, naglalagay pa tayo ng sulfur. So technically, pahaba ng pahaba yung chain. Mas mahaba ang chain, mas rubbery. Kaya kung makita niyo sa example, yun yung principle na ginagamit sa vulcanized rubber. Kasi mas malambot na siya or mas rubbery siya kasi meron na siyang pinahaba ng element of sulfur yung compound series of chemical chain of molecules. Next po. Crystallization is just a paradox of heat treating. Unlike heat treating, nagsisimula sa pagkatunaw mo ng crystallization in a liquid state. And unlike also heat treating, ito naman, ang heat treating kasi is pag nag-apply ka ng heat is technically tumatas yung temperature, while in crystallization, there's a drop of temperature. Pag nagkakaroon drop ng temperature, nawawala excitation ng molecules, mas nagiging mahina yung paggalaw nila. Magmahinang paggalaw nila, nagdidikit sila, stick together, mas lumalamig yung paligid, so nagki-crystallize sila. Ganun lang po kasimple yun. Next. Melting, which is nabanggit sa part ng heat treating. Pinagkaiba po ng heat treating at melting is technically, melting is just a process of heat treating. Heat treating is the application of heat, while melting is a certain point where the heat is already applied. So, it has, an object in a solid piece will eventually turn in a liquid state. Ganun lang po yun. Next po. Glass transition is quite confusing po kapag sinunod natin sa melting. So to distinguish this, I created an analogy all about that. Glass transition is same lang po with melting po, halos. Ang pagkakaiba po nila, bali dun muna po sa similarity. Bali, ang pagkakaparas po nila is nagsimula sila in a solid state and medyo lalambot sila. Ang kinagkaiba nila ay, ang melting is from solid, compact solid. Then will eventually turn into a liquid state, total liquid. While glass transition is a solid amorphous commonly happening in an amorphous solid, not just solid, specifically amorphous solid. Amorphous solid that will eventually into a rubbery solid. Rubbery solid, medyo malambot na siya, at the same time solid pa rin. So, ang example dyan is ice. Sa melting, technically, pag nag-apply ka ng heat, yung ice will eventually turn into a water. While sa glass transition is candy. Kapag nag-apply ka ng heat sa isang solid like candy, hindi naman siya mag-turn, hindi siya magiging tubig, magiging rubbery siya, magiging malambot siya. Siguro kung meron dito may mga tindahan, kapag na-stuck yung candy sa isang storage room, mapapansin nyo yung ganong example. Next po. Different types of polymers, which is I will be focusing on plastics lang po muna. Proceed sa next slide. Yan po. How is plastic made? Will be played by Mr. Orlando po. Rinig po ba?
Hindi po.
Bali siguro, play na lang siguro yung link sa YouTube po. Mismong YouTube. So since di po siya ma-play, explain ko na lang po in my own words which is based on the ano po sa video po. Technically, plastic is not ano po, visualized former, I mean ano po, from the past po. So nagkameron po ng ano po ng pagka-discovery ng plastic due to need na din po ng kailangan nating mga bagay. Like, ano pwede natin gamitin sa ganito, ano pwede natin gamitin sa ganito. So, with innovation, nag-decide yung mga tao na gumawa ng something, material, synthetic material na magkakos para mapadali pa yung paggamit natin isang bagay sa specific field, which is madidiscuss mamaya, mainly. So, sa madaling salita, plastics mostly are made from tinatawag nating crude oil or fossil fuel, which is yung mga fossil fuel is kung may mahilig sa inyo dito sa dinosaur is yung time ng mga Triassic, Jurassic, is merong mga malaking puno na matay and napailaliman ng lupa and na-develop yun. Yun yung tinatawag na fossil fuel. And through to chemical processing, mas na-disintegrate yung mga chemical and kapag binuo mo siya sa certain type, yung katulad nga sabi natin na may ginagamit na heat treating, melting, gas transition, makagawa ka na iba't ibang uri ng plastic. So yun lang po, ganun lang po kasi. Proceed na po. So, gaya nga po nasabi ko kanina, marami pong uri ng plastic po. May dalawa pong uri. Una po yung thermoplastic. Discuss ko na din po yung thermosetting na tinatawag. Thermoplastic sa madaling salita is a type of plastic na kapag inilagyan mo ng heat, may application ng heat, matutunaw. Pag natunaw, matutuyo, babalik pa rin sa pagiging plastic. While thermosetting, different from thermoplastic, ang kinaibahan niya is when there's an application of heat, magkakameron ng disintegration ng particles. So technically, masusunog siya. Magbe-burn, magkakaroon ng fumes. So madaling salita, mas padaling pa po natin. Thermoplastic is reversible, while thermosetting is irreversible. So magbigay naman po tayo ng ng examples po ng thermoplastics. The first one is acrylonitrile butadiene styrene or ABS. Para po ma-distinguish po natin what is acrylonitrile butadiene styrene, the first polymer is also known as acrylonitrile. Acrylonitrile is responsible for rigidity kasi po may nitrile siya, and butadiene is for resilience niya po, and styrene is for glossiness. Magagets niyo po kapag nagbigay ako ng example. Yung trade names naman po, para po mapabilis tayo, trade names is just a brand po. Technically, yung Abson, Cyclop, Pralistic, Lustron, Lucon, Lubodor is yung brand na ina-accompany nila sa kanilang process, yung certain type of material. So, ano nga bang materials ang pwedeng magawa using ABS? Lego bricks. Ganun po. Kaya po sabi ko kanina, tatlo po silang component of polymer. May glossiness, which is matatagpuan din natin sa Lego bricks. May rigidity, alam naman po natin na hindi po basta-basta masisirang Lego. And resilience, yung pagiging niyo po niya, hindi masyadong fragile. Alam naman po natin kung gaano katigas ang Lego. Gaano po kasimple. ABS has a high impact resistance. Yun na nga po. Good heat resistance and toughness and durability. Aside from Lego, mayroon pa po tayong example like automotive parts like helmets. Alam po natin na due to dahil nga po sa pagkakameron po niya ng rigidity, ABS is one of the most useful type of material that can be used on helmets po, when making helmets. Acrylics, kung meron po dito art inclined or technically mahilig sa mga arts, magigets nyo po agad dyan. Acrylics, also known as polymetal metacrylic. Siya po ay in a liquid form which is nanggaling po sa tinatawag nating acrylic acids which hardens kapag na-expose sa air. Isang example po yung is pintura. Ang pintura naman po ay natutuyuan once it style. Meron din po siyang property. Hindi po lahat na acrylic ibig sabihin po ay colored. Commonly po, yung base acrylic po is known for its transparency and clarity, UV resistance, hard surface hardness, and scratch resistance. Kaya po, kalimitan ginagamit din po siya sa fish tanks. Aside from using glass, kung gusto niyo po ng cheaper, magagamit niyo po yung acrylic. Kasi safe po siya gamitin, lalo kahit po ma-expose siya sa living organism, hindi po siya makakapinsala. The next one is what we call PTFE or polytetrafluoroethylene. Sa madaling salita po, ito po ay isang high-performance synthetic fluoropolymer. Alam po natin na fluorine is such a toxic na na element. So paano masasabi na mapapakinabangan natin yung tinatawag na PTFE? Kalimitan po ginagamit po siya sa non-stick cookware. Ang ironic, di ba? Kasi kinakainan natin yon. So for it to become useful, gumagamit po tayo ng tinatawag na coating. Kasi po, kaya po ginagamit niya siya sa non-stick pan kasi po isa sa pinaka-unique trait ng PTFE is kaya niya po mag-resist partially resist ng friction. So kapag yung mga non-stick pan, alam na po natin kahit kuskusin natin yan, ay hindi siya magagasas. So paano nga ba napapakinabangan siya? Hindi siya naging toxic. May coating nga po, which is yung kalimitan mga Teflon. Yun po. The next one is nylon. Kung meron dito sa inyo mahilig gawa ng mga bagay gamit yung PC, also known as PC siya, pero technically hindi siya basta PC lang. Nylon is a polyamides. Kalimitan pong ginagamit ang nylon sa, wait lang po, rope. Yun nga po, ganun kasimple lang yun. Kasi nga po, pero hindi siya basta rope. Kasi technically, meron siyang high tensile strength. Pagkakaroon ng tensile strength, ibig sabihin hindi siya basta-basta mapuputol. Next po. Polycarbonates is a type of thermoplastic known for their high impact, resistance, and transparency. Ang pinaka-unique po na trait ng carbonates, sa madaling salita, tandaan nyo lang po yung term na transparency. Marami na po nabanggit na may transparency kanina, pero isa po ito sa pinaka-unique na way of showing their transparency kasi it is accompanied with high resistance po sa temperature. Alam naman po natin, magbigay muna po ng example. Ginagamit po ito sa mga shades. So alam naman po natin, para makita tayo is kailangan po natin ng clarity talaga and transparency. And alam naman po natin na tinatamaan ng init ng radiation yung mismong glasses ng salamin. So for it, para po dito, para magamit natin maayos, so kailangan natin ng material na meron ding high resistance sa ganong kapwa na temperature. So technically, polycarbonates are mostly used to that kind of material po, to that kind of object po, or product, eyeglasses. Next po is polyethylene, which is nadi-divide sa dalawang klase, which is HDPE and LDPE. Kung natatandaan po natin, yung tinapik po ni ma'am, trivia lang po, kung titingnan nyo po yung ating mga gamit sa bahay, may matatagpong kayong label sa ilalim niyan. Yung po kasi is the reason kung ba't malimit siya makikita is kalimitan po sa bahay po, ang ginagamit, mga gamit sa bahay po, ang ginagamit po is yung PE po, polyethylene. Una po dun eh, high density po, ibig sabihin mas malakihan yung dense na ginagamit na, which is kalimitan tatapuan sa tabo, sa timba, sa jugs, sa bote. While yung naman po, kung matatanda niyo po na sinabi din po ni ma'am, yung low density po ay yung sa maninipis lang po, like plastic labo. The next one is the PP o polypropylene. Polypropylene is affordable din po, pero unlike polyethylene, medyo hindi po siya masyadong used. Kasi po, mas focus po siya sa food packaging po. Mura din po siya kagaya ng polyethylene, pero hindi po siya ganong rigid katulad ng polyethylene. So technically, sa food packaging lang po siya for storage. Like baonan po. Cheap din po siya katulad ng polyethylene. Then the next one is polystyrene, also known as styrofoam. Gaya nga po na sabi ni Ms. Landitzo kanina. Pero po, one of the dito, pinagkakamali ng tao kapag sinabing styrofoam is just a styrofoam na lumulutang. Trivia lang po, polystyrene is also used sa ginagamit natin kapag may handaan, which is the disposable na spoon and fork. Bali po, para mas matandaan po siya, yung may mga poly po yan, polycarbonates, polyethylene, polypropylene, polystyrene. Yan po yung mga product ng plastic na commonly nabibili natin na may cheap price. Pero commonly nga po, polyethylene yung pinaka-cheapest. Next one is next po, vinyl or polyvinyl chloride. Kaya nga po din po sabi ni Ms. Landitzo kanina, PVC po yan sa madaling salita. Yun lang po, ganun kasimple. Bakit nga ba saan nga ba ginagamit yan? Polyvinyl is commonly used sa piping. Bakit? Kasi ductile yan. Mas madali, alam naman po natin na when there's an application of heat, madaling iibuin na lang yung tubo. And bakit siya ginagamit niya sa tubo? Alam naman po natin na malilinis na bagay dumadaan doon. It's because sa type ng plastic, vinyl po ay nabibilang po sa pagkakaroon ng chemical resistance na property. So madaling salita, pag ginamit natin siya, malalasin yung hazardous effect ng mga bagay na dadaan doon. And the next one is the PET or polyester. I know, mali po yan. Na-check ko na po yan. Bali po yan po ay polyethylene terephthalate. Sinasabi po ni Ms. Landicho. Polyester is thermosettings po siya naka-conclude. Bali po, ang PET po ay meron po siyang high transparency, high tensile strength, and barrier properties. Kaya po din na nasabi doon ni ma'am, kung maalala niyo po, commonly ginagamit niya sa beverages. Kasi po yan po ay grease resistance po. So technically, pag may nilagay diyang inumin, mas mapoprotektahan yan. Yung po ay example ni ma'am dati po. Next po. Thermosettings. Gaya nga po sabi ko kanina, thermosettings, unlike thermoplastic, is irreversible siya. Once na there's an application of heat, magkakameron ng fumes, which is exposed to air which is delikado din talaga para sa tao natin. One of them is called epoxies, ang example ng thermosetting na polymer. Kung may nakakaalam po sa inyo dito, like na mga pig urines, na ginagamit po sa anime figure, like ganun po, like mga Funko, isa po yun sa ginagamit po, yung mga epoxies. Kasi po, epoxies is po known for its adhesive. Mas madikit po siya. Pero, once na ginamit po epoxies, is kailangan po well-ventilated po yung lugar. Kasi nga po, toxic po siya. The next one is phenolics. Phenolics is, feeling ko, familiar siya sa inyo sa idea na phenol. Kasi, ginagamit din yan sa medicine. Isa sa trait ng phenolics ay may high resistance siya sa init tsaka sa corrosion. So technically, aside from using that sa medicine, pwede mo rin siya mapakinabangan sa ibang bagay pa. The last one is polyester. Yung sinabi ko nga po pinagkaliwan kanina. Kung mahilig po kayo magplansya ng damit, malalaman niyo po yan. Polyester, alam naman po natin, pag napaso yan ng sobra is masusunog siya. So malalabel siya as thermosetting. Polyester, example niyan is, kagaya po sabi ko kanina, damit. Kasi po meron siyang creep resistance po. Ibig sabihin, hindi siya basta masisira and kaya po siya ma-form into thin wirings po. Thinner na which is good for our skin. So polyester is one of the best type of thermosetting that can be used in clothing. Yun na po. Salamat.
Now, proceed naman po tayo sa properties of elastomer. Kung makikita niyo po sa table, has 5 properties po, which is the natural rubber, the SBR, NBR, neoprene, at silicone. But first po, alamin po muna natin what is elastomer. As said nga po ni Mr. Cedric, ang elastomer po ay isang special type of polymer kung saan ito po is very elastic. Kung saan po kapag po nag-stretch tayo ng isang bagay like ang rubber, is nagkakaroon po ito ng permanent changes sa polymer structure. Kung saan po hindi na po natin maibabalik yung kanilang natural sizes. And dun naman po pumapasok ang ating elastomer dahil nga po hindi maibalik yung natural size ng isang bagay kapag in-stretch is dahil po ang elastomer po ay mayroong high elongations to break. Saan po kapag sobra nating binanat ang isang bagay, hindi na nga po babalik ito, and kapag tinodo natin ang pagbanat nito ay maaari na po itong mabali o masira. Then, bibigyan ko po kayo ng konting kaalaman para sa properties of elastomer about po dito sa 5 properties. Ang first one po is ang natural rubber. Indicated naman po na natural, it means po, it occurs po naturally sa nature, kung saan sa mga halaman, sa mga puno. At ang pag-process naman po sa natural rubber na ito ay tinatawag po nating latex. Then, dito po sa natural rubber is meron po siyang excellent mechanical properties. Also rin po, meron din po itong excellent tensile, elongation, tear resistance, and resilience. At dahil po sa mga ito ay meron din po itong good abrasion resistance at merong mababang temperature flexibility. Kung saan Ang natural rubber po, kapag po wala po itong special additives, ay magiging mababa po yung resistance po nito sa ating ozone, oxygen, sa sunlight at sa heat. At dahil nga po mababa nga po ito, for resistance ay mababa rin po sa solvents at petroleum products. Next po is ang SBR, styrene butadiene. Ang styrene butadiene naman po ay ito po ay isang copolymer of styrene at butadiene na nagkakaroon din po ng ito po ay may similar properties po sa natural rubber. Kung saan po it resistance po is sa solvent and petroleum products ay natural same po sa natural rubber. And dito po sa SBR, ang mas mabuti po dito is water resistance. And without special additives naman po dito ay ito po ay magiging vulnerable sa ozone, oxygen at sa sunlight. For the third properties naman po which is the MBR, ito naman po ay isang copolymer of acrylonitrile at butadiene kung saan meron po itong excellent physical properties at kiniklaim po nito na it is flame-based sa water resistance, also sa petroleum product at sa fuels. And also, it is compounded properly. Tapos, meron naman po itong mababang temperature at heat resistance. At dahil nga po, pag po wala po itong special additives, ay hindi po maganda ito sa ating ozone, oxygen, or sa sunlight naman po. Then, for the fourth one naman po is ang neoprene. Dito naman po sa neoprene, ito po ay isang elastomers na made by polymerization of chloroquine na kung saan merong excellent physical properties at it moderately resistant sa petroleum products tulad din ng sunlight, ozone at sa heat. And for the last one naman po is ang silicone. Alam naman po natin kung ano silicone, di ba? Tapos, ang silicone naman po is made galing sa sand at alkyl or aryl halides. Ito naman po is predominantly inorganic material naman po dito kung saan ang silicone po is may mataas na outstanding resistance sa mataas na temperatura. At ito po ay meron din pong excellent vibration damping at reasonable physical properties tulad po ng sa tensiles at sa elongations. Pero pag naman po sa tear and abrasion resistance is mababa po dito ang silicone. Next po. Dadako naman po tayo sa second type of polymers which is the fibers. Ang fibers po is capable of being drawn into long filaments na may length of 100 and diameter ratio po ng 1. And dito po sa fibers, it is commercially used po ito sa mga textile industry. And ginagawa po ang fiber kapag woven or ito po ay knitted para po maging cloth or isang fabric. Also, ang fiber po is subjected sa mga variety of mechanical deformations tulad nga po ng stretching. Like, ang fibers nga po is mayroong high flexibility kaya meron din po itong sa stretching, twisting, shearing, and abrasion. Also, ang fibers po ay yun nga po may high tensile strength and high modulus of elasticity as well as abrasion of resistance. Next po. For the third type of polymer naman po is ang coating. Alam naman po natin kung ano ang coating. Ito po yung isang surface engineering point of view ng pagle-layer natin ng isang material para po maiwasan po ito ng corrosion at magkaroon ng wear protections. Dito po naman sa coating, ang advantages naman po nito sa mga material na ginagawa natin is mapoprotektahan nga po nito ang isang items sa mga pagpuproduce ng corrosive or deteriorative reactions. Also, may improve po nito ang isang item's appearance at nakakapag-provide ng electrical insulations. And there are different classifications naman po ang coating, maaring paint, varnish, enamel, lacquer, at shellac. Next po. For the fourth type of polymer, adhesive. Ang adhesive naman po, ginagamit po natin kapag pinagbabad natin ang isang two solid materials. Pinagbabad po natin yung surfaces ng dalawang solid materials. Ngunit, ang adhesive po is nagagamit lang kapag ah, large variety ang materials katulad ng metal, ceramic, polymers, composites, skin, at madami pa. And magagamit lang po natin ang adhesive. It depends po sa mga factors ng isang material. Tulad ng kung ang material po is to be bonded and their porosities and the required adhesive properties. The third po is yung maximum and minimum exposure temperature ng isang materials at ang last one po is ang processing conditions. Next po. Next po is film. Ang film naman po is meron po itong kapal between 0.025 and 0.125 mm. Converted to inches is 0.01 and 0.005 inches. Ang films naman po is pinabricate at ginagamit lang po extensively as bags para po sa mga food packaging, products, and sa mga other merchandise. Also, na rin po sa mga textile products. And more important naman po ng more important characteristic naman po ng films to produce materials ay meron po itong low density, a high degree of flexibility, high tensile and tear strength, and resistance to attack by moisture. Also, in other chemicals naman po, ang films po ay mayroong low permeability to some gases, especially po sa water vapor. Next po. For the last po type ng polymers is ang foams. Ang foams po na pwede pong example is yung sa mga styrofoam po na nilalagyan natin ng pagkain, kaya and yun nga po, dahil ang foams po is isang plastic material na nagko-contain po ng high volume percentage of small pores and trap gas bubbles. Ito po ay mayroong thermoplastics and thermosetting materials as said nga po din na in-explain ni Mr. Cedric June. And ang foams po ay commonly used po as a cushion sa mga automobiles and furnitures. Also din nga po sa mga packaging and thermal insulations. And ang pagpaprocess naman po ng foaming is carried out by the incorporating into the batch of materials a blowing agent that upon sa heating, decomposes with the liberation of gas. Next po.
Ay naman po ay let's talk about the advanced polymeric materials. Then ano nga po ba yung advanced polymeric materials? The advanced polymeric materials essentially consists of two components materials. First is the matrix materials or polymers, which is generally the low strength and low modulus component. And the second is the fiber, which is the relatively high strength and high modulus component. Next slide po. So, ang una po is ultra-high molecular weight polyethylene. It is a linear polyethylene that has an extremely high molecular weight of 4 times 10 raised to 6 gram per mole, which is an order of magnitude greater than that of high-density polyethylene. In fiber form naman po, ultra-high molecular weight polyethylene is highly aligned and has the trade name of spectra. Then diyan po sa illustration, makikita po natin yung kanilang structure in melt condition and in solid condition. Then, ultramolecular weight polyethylene is subset of the thermoplastic polyethylene, also known as high modulus polyethylene. It has extremely long chains with a molecular mass usually between 3.5 and 7.5 million MAU. Next slide po. So we have here the extraordinary characteristic of ultra-high molecular weight polyethylene. First is it has an extremely high impact resistance, outstanding resistance to wear and abrasion, a very low coefficient of friction, a self-lubricating and non-stick surface, a very good chemical resistance to normally encountered in solvents, then excellent low temperature properties, outstanding sound damping and energy absorption characteristics, and lastly, is electrically insulating and excellent dielectric properties. Then, next po, next naman po is liquid crystal polymers. Liquid crystal polymers are the group of chemical complex and structurally distinct materials that have unique properties and are used in diverse applications. It have an outstanding mechanical properties at high temperatures, excellent chemical resistance, inherent flame retardancy, and good weatherability. It composed of extended rod shape and rigid molecules. In terms of molecular arrangement, this material do not fall within any of conventional liquid, amorphous, crystalline, or semicrystalline classification, but may be considered a new state of matter. The liquid crystalline state being neither crystalline nor liquid. In the melt or liquid condition, liquid crystal polymers molecules can become aligned in highly ordered configuration. So now let's proceed to the application of liquid crystal polymers. It is used in electrical parts electronics such as connector, sockets, and chip carriers. Mechanical part, food container, automotive underhood parts, and chemical processing and household cookware for conventional and microwave ovens. Then, due to its lightweight and stable property, uh, it provides superior loads handling characteristic for tow ropes, cargo tie downs, and inflatables. It is useful for electrical and mechanical parts, and one of the most famous and classical application of liquid crystal polymers is Kevlar, a strong but light fiber with wide application. Notably, bulletproof vest. Yan, makikita po natin dito sa picture yung isa po sa example nito is yung bulletproof na ginagamit po ng ating mga next slide po. Next is thermoplastic elastomers. It is a type of polymeric materials that at ambient conditions, it exhibits elastomeric or rubbery behavior yet is thermoplastic. It is sometimes referred to as thermoplastic rubbers, a class of copolymers or a physical mix of polymers, which is usually a plastic and rubber that consists of materials with both thermoplastic and elastomeric properties. It have several advantage over conventional thermoset rubbers and plasticized thermoplastics. For a common thermoplastic elastomers, hard polymerized segments are located at chain end, whereas each soft central region consists of polymerized butadiene or isoprene units. So, saan nga po ba natin makikita ang materials na to? Next slide po. So, makikita po natin siya sa mga automotive Then sa construction po, ang example po nito sa construction ay yung mga door seals po and window seals. Then sa consumer's good naman po ay yung mga magnetic seals ng ating mga refrigerators, power tools handles, remote control covers, and maging sa ating mga mobile phone covers po. Then sa medical naman po is breathing tube, syringe seals, ventilation mask, bags, seals, bulbs, and catheters. Then sa electronics naman po, ang example po nito ay loose socket, specialty cables, and mobile phone components. Then sa footwear naman po ay yung mga diving such as flippers, snorkels, and masks. Tapos sa skiing naman po ay yung mga sky boots. Then sa industrial naman po is yung anti-vibration mounts, inlet pipes, exhaust manifolds, seals, drum suspension bushes, shocks absorbers, and roof membranes. Makikita po natin dito sa picture, kalimitan po is sa mga sport shoes. Then, kasi nga po, kilala po siya sa pagkakaroon ng lightweight. So, sa mga sasakyan po is, ano po siya, known po siya for contributing to lighter vehicle weight for fuel fuel efficiency. Then next po, now, now is polymer synthesis and processing. Next po. Ang una po is polymerization. It is the process to create polymers, and these polymers are then processed to make various kinds of plastic products. Through polymerization, synthesis of high molecular weight polymers is attained, of which there are two types, which is addition and condensation. Monomer units are attached one at a time in a chain fashion to form a linear molecules. So, during polymerization, smaller molecules called monomers or building blocks are chemically combined to create larger molecules or micromolecules. For better understanding po, we prepared some short clip about polymerization.
Welcome to Smart Culture. Hey, don't forget, hit the like button down below and subscribe to our channel.
In this video, we'll discuss monomers, polymers, and polymerization. So, what is a monomer? Well, a monomer is just a small organic molecule. A monomer can react with other molecules to form very large molecules or polymers. This process is called polymerization. So what do we have here? We have monomers, polymers, and the process of polymerization. Let's write out the formal definitions of these terms. Monomers are small organic molecules that can form a repeating pattern when covalently bonded to one another. A polymer is a big molecule made up of smaller monomer units that are covalently bonded to one another in a repeating pattern. Lastly, let's look at polymerization. This is a process through which a large number of monomer molecules react together to form a polymer.
For online tutoring or additional resources, visit our website www.smartculture-education.com.
Subscribe down below. It's easy.
So, ang next po is condensation, or a step reaction polymerization. It involves stepwise intermolecular chemical reaction that may include more than a single molecular species. Is the formation of polymer by stepwise intermolecular chemical reaction that may involve more than one monomer species. It has no reactant species has the chemical formula of the repeat unit, and the intermolecular reaction occurs every time a repeat unit is formed. Then the reaction between monomers unit and the growing polymers chain and groups releases a small molecule, often in water. The condensation polymers form more slowly than addition polymers, often requiring heat, and they are generally lower in molecular weight. The terminal function groups on a chain remain active so that groups of shorter chains combine into longer chain in the late stage of polymerization. The presence of polar function groups on the chains often enhances chain-to-chain attraction, particularly if this involve hydrogen bonding and thereby crystallinity and tensile strength. Next po. Next is addition polymerization or chain growth polymerization. It is a chain reaction adds new monomers use units to the growing polymer molecules one at a time through double or triple bonds in the monomer. Addition polymer formed by polymerization of unsaturated monomers that typically contains a CC double bond. Important addition polymer include PE and PBC, which are formed by polymerization of ethane and vinyl chloride. Addition polymer are formed of chains of carbon atoms with strong CH bond and are resistant to biodegradation. It could also be formed through ionic polymerization in which the active center carries either a positive ion or cation or a negative ion or anions. The chain reaction proceed through either a cationic reaction or anionic reaction. Ionic polymerization are more highly selected than radical processes due to strict requirements of stabilization of ionic propagating species. The next po. Ito po yung mga example ng polymer additives. The properties of polymer may be further modified by using additives. Fillers are added to improve the strength, abbreviation resistance, toughness, and thermal stability of polymers. Flexibility, ductility, and toughness are enhanced by addition of plasticizer. Stabilizer counteract deteriorative processes due to the exposure to light and gaseous species in atmosphere. Then colorants are used to impart specific colors to polymers. Then last is the flammability resistance of polymers is enhanced by the incorporation of flame retardants. Next po. Ang next naman pong topic is forming techniques for plastics. Ang una po is molding. Next slide po. Bago po pala tayo mag-select ng techniques for forming plastic, meron po tayong dapat i-consider na factors. One po is whether the material is thermoplastic or thermosetting. If thermoplastic, the temperature at which it softens, the atmospheric stability of the material being formed, and the geometry and size of the finished product. Next po. Ito na po ang molding, the most common method for forming plastic polymers. And then the several molding techniques used include compression molding, transfer molding, blow molding, injection molding, and extrusion molding. Let's talk about the compression molding. Next po. Compression molding. For compression molding, the approximate amount of truly mixed polymer and necessary additives are placed between male and female molder. Yan po, makikita po natin dyan sa illustration. Wait lang po. Okay. Ang step po dito is, ang una po is the product is heated until somewhat soft and pliable. Then a hydraulic tool presses the material against the mold. Then once the material is hardened and has taken shape of the mold, it is ejected. Then the final product will require additional work such as cutting away the flashing. And somehow naman po, ang other materials po will be ready immediately upon leaving the mold. Next po. Yan po yung video.
Compression molding. Let us see the basic compression molding process. Upper mold half, punch, charge. Lower mold half, knockout pin. For molding, the upper mold half, compress the charge and fill it into the cavity. Then, the molded part is ejected by knockout pin.
Next topic po is transfer molding. In transfer molding, aberration of compression molding, the solid ingredients are first melted in a heated transfer chamber. As the molten material is injected into the mold chamber, the pressure is distributed more uniformly over all surfaces. This process is used with thermosetting polymers and for pieces having complex geometries. Yan nakikita po dito sa pictures. Then, pa-play po nung video para po mas maintindihan natin tong transfer molding.
Transfer molding. Transfer molding is a modification of compression molding. A typical transfer molding machine has control unit, actuator, punch, charge, and mold cavity. In transfer molding, the thermosetting charge is loaded to transfer pot and heated. Then, the charge is allowed to flow into an orifice mold by applying pressure. Transfer pot. After the solidification of charge, the molded product is rejected from the mold cavity.
Injection molding. Injection molding is the polymer analog of die casting. For metals, it is the most widely used technique for fabricating thermoplastic materials. See, injection molding is a versatile and highly efficient method for mass production of complex and precise components with consistent quality. It is also used in widely various industries, including automotive, consumer goods, electronic, medical devices, and more. To create complex shapes, effectively produce large quantities, and provide design flexibility makes it a popular choice for a wide range of application. Ang advantages nga ni injection molding is have a high precision, efficiency, material variety, low waste, at saka si consistency. Ang nakikita niyong figure is the injection molding machine. Next po. And this is how injection molding machine works. Una nga po is material preparation. The process begins with the correct amount of pelletized thermoplastic material being fed from a feed hopper into a cylinder. Sumunod nga po si heating and melting. In heating and melting naman po, si material charge is pinupush niya into a heating chamber where it is forced around the spreader to ensure better contact with the heated chamber walls. Next po dun is the injection, which molten plastic is impelled once again through the motion of the ram through a nozzle into an enclosed mold cavity. The nozzle ensures a controlled flow of the material into the mold. Sunod na nga po na mangyari dun after nun ay yung cooling and solidification. After po ng At this part naman po, the material within the mold cavity is allowed to cool and solidify. This step is carefully controlled to ensure the part takes on the desired shape and properties. And after that po is si mold opening. After the molding has solidified, the mold is open, revealing the finished product inside. After nga po nun, mag-eject na an ejector mechanism such as ejector pins that pushes the finished part out of the mold cavity. And lastly is magsa-cycle repeats na po. Para mas maintindihan nyo yung injection molding machine works, may mag-play ko ng video si Early. Next po. In summary lang po ng injection molding, it is known for its ability to produce high precision and detailed cards with high tolerances efficiently. Katulad nga ng sinabi ko kanina, it offers several advantages including rapid production, versatility in material selection, and consistency in part quality, making it a widely adopted manufacturing method for a diverse range of industry. Ang next nga po na type of molding is extrusion. So extrusion daw po is molding of a viscous thermoplastic under pressure through an open-ended die, similar to the extrusion of metals. It also a manufacturing process used to create continuous length of uniform cross-sectional profiles or shapes, primarily from thermoplastic and elastomeric materials. This process is commonly employed to produce products such as pipes, tubing, seals, gaskets, and various other plastic or rubber components. They have several types of extrusion molding. The first one is profile extrusion, where used to create product with specific cross-sectional profiles such as window frames, door seals, or complex gasket. In tube and pipe extrusion naman po, it is designed for the production of cylindrical and tubular product like plastic pipes, hoses, and tubing. In blown film extrusion naman po, used to create thin plastic films, often for packaging application. And the last one is sheet extrusion, which utilized to produce flat plastic or rubber sheets of varying thickness for application like thermoforming and packaging. Next po. Uh, how extrusion molding machine works. Katulad po na kanina, material feed, melting and compression, extrusion die, cooling, and solidification. Ang advantages po na extrusion molding is have a high efficiency, cost-effective, wide material compatibility, and precision and consistency and versatility. While ang disadvantage naman po niya is have a limited to continuous profiles, tooling costs, material limitations, cooling and solidifications challenges, limited surface finish, and complex die design. Para mas maintindihan niyo po kung paano nagwo-work or nagpa-process ang extrusion molding, i-play pong ulit na video si Orly. Next po. The next type of molding po is blow molding. Blow molding is a manufacturing process used to produce hollow plastic or polymer parts, primarily containers, and bottles with a variety of shapes and sizes. This process is widely used in the packaging industry for producing items like bottles, jars, and containers for beverages, personal care products, and household items. It is typically used for the production of large quantities of plastic containers, making it an efficient and cost-effective manufacturing method. The blow molding have several advantages, including efficiency, versatility, reduced material waste, lightweight. And this is how blow molding machine works. The first one is extrusion of parison, clamping the mold. Next is blowing and forming. Next, cooling and solidification, molding, opening, and injection, and the final product or the finished product. To para mas maintindihan nyo ng ayos, may papakita ulit na video si Org. Next po.
Our shops and supermarkets are filled with products that are packaged in plastic, produced using blow molding technique. The plastic blow molding process is the most popular method used to produce hollow containers. Impact uses a variety of raw material during the blow molding process, depending on the container application and its expected performance. The raw material in granular form is fed via a hopper into the feed barrel, which is heated to help melt the granules and evenly disperse the colorant, called master batch. A molten tube of plastic, called a parison, is extruded from the machine head and cut with a hot blade. It is then captured by a water-cooled mold, and a blowing nozzle is inserted into the parison. A blast of pressurized air is blown into the parison, forcing the hot plastic to take on the shape of the mold. This process is called blow molding. Once cooled and solidified inside the mold, the machine opens the mold and the brand new container is ejected. The container is transferred to a deflasher that removes the excess known as the tail. This excess is conveyed to the beginning of the process to be ground and reused. This is known as a closed-loop system. Once the jars leave the machine, they are then conveyed to a trimmer, which removes the remaining excess, called the lost head, which in turn is collected and added to the closed-loop system. With the tail and lost head removed, the plastic jar or container is now in its final form. Bottles are subjected to a leak test whereby controlled airflow is released into the bottle. Should the bottle contain any leak-related defects, the pressurized air will escape and the bottle will be rejected. This bottle will then be introduced back into the closed-loop system. The containers are now ready to be packaged and sent on to the manufacturers of the products who will fill the new container.
Next po. Ang last nga po is si casting. Casting is a common method for shaping and forming polymeric materials including both thermoplastic and thermosetting plastic. The process differs slightly for these two types of polymers. The first one nga po si casting thermoplastic. For thermoplastic materials, the casting process involves melting the plastic typically in a molten state and then pouring into a mold. The plastic solidifies as it cools and takes on the shape of the molds. This solidification process is solely due to cooling and does not involve a chemical reaction or cross-linking of polymer chains. Once cooled, the part can be demolded and is ready for use. While the casting thermosetting plastics naman, as casting thermosetting plastic on the other hand is more complex. Thermosetting plastics undergo a chemical transformation during the casting process. Next po. Fabrication of elastomers. Next po. Elastomers are a class of polymeric materials characterized by their unique elastic and rubbery properties. These materials are known for their ability to return to their original shape after being stretched or deformed. Elastomers are used in a wide range of applications where flexibility, resilience, and the ability to absorb and recover from deformation are essential. Next po. Ang key characteristics nga po ng elastomers ay elasticity, which can stretch or compress. Next ay high strain at break. Can undergo significant deformation before reaching their breaking point. Third is low tensile strength. While they have a high elasticity, elastomers generally have low tensile strength, which means they are not as strong as materials like metals or engineering plastic. Low compression set. Elastomers have excellent compression set properties, meaning they can maintain their shape and sealing properties even when subjected to prolonged compressive forces. And the last one is the good resilience. Elastomers can absorb energy and then release it when deformed, making them useful in application where shock absorption or damping is required. And elastomers are widely used in various industry and application including automotive. Nasabi na po to kanina sa report ni Catherine. So, automotive, construction, consumer goods, medical devices, industrial sealing, and in sports and recreation. Next po. Fabrication of fiber and films. Next. Fiber. Fiber polymers refer to the type of polymers used in the production of fibers. Polymers are large molecules made up of repeating units known as monomers. In the context of fibers, these polymers can be natural or synthetic materials that are processed into long, thin strands with specific characteristics. And here are some common types of fiber polymers. The first one nga po is synthetic polymers. These are man-made polymers that are widely used in the production of synthetic fibers. Ang example includes nga po dito si polyester na in-explain ni Cedric Jun kanina, nylon, polypropylene, at saka si acrylic at spandex. The second po ay si natural polymers. Some fibers are derived from natural sources and are made up of naturally occurring polymers. Ang examples naman po dito is cotton, wool, silk, and silk. Next po. The process of forming fibers naman po ay the process of forming fibers from bulk polymer material is known as spinning. Most commonly, fibers are created through a method called melt spinning. Here's a breakdown of the key steps in melt spinning. One nga po ay si heating. The material to be spun is heated until it reaches a relatively viscous liquid state. Ang second nga po si spinner. The heated materials is then pumped through a device called a spinneret which contains numerous small, usually round holes. And the third po ay si fiber formation. As the molten materials flows through each of these orifices, it solidifies to form a single fiber. This rapid solidification is achieved by cooling the newly formed fiber with the help of air blowers of a water bath. Next. To enhance the strength of fibers, a post-forming process called drawing is commonly employed. Drawing involves the permanent mechanical elongation of the fiber in the direction of its axis. During this process, the molecular chains... Yes pa. Yes po, ma'am.
Okay lang na next meeting na natin siya ituloy.
Ma'am, last
Sorry po.
na po, topic.
Sige. Okay po, makikituloy na.
The cross-sectional shape of melt-spun fiber is typically nearly circular and their properties are uniform throughout the cross-section. The two techniques nga po dito is si dry spinning and wet spinning. Si dry spinning po, in this method, the polymer is dissolved in a volatile solvent. The polymer solvent solution is then pumped through a spinning it into a heated zone where the fiber solidify as solvent evaporates. While in the wet spinning po is involves passing a polymer solvent solution through a spinner directly into a second solvent. Next po. Films. Films. Film polymers refer to a polymer that are used in the production of thin films. Thin films are continuous layer of material with a thickness ranging from nanometers to micrometers. Some common types of film polymers include nga po ay na-discuss na din po ito ni Cedric yun kanina. Yan. Next na. Yan. Production of films na lang. The production of films involves various manufacturing process and different techniques are used to create thin films with specific properties. Here are some common methods for manufacturing films. One is extrusion. Next po is si blown film at saka ang last po is si co-extrusion. The choice of manufacturing method depends on the specific requirements of the film, including thickness, strength, transparency, barrier properties, and more. These techniques are commonly used in the production of films for application like packaging, plastics, construction, and various industrial uses. Tapos na po.
Okay, so next meeting na lang po natin itutuloy ha. Makiki-open na po ako ng camera. Ano na po ako ng presentation. Nasa labas po ako. Mababa po ako mula sa... Sino po mag-screenshot? Sino po mag-screenshot po?
Yes po, Mama Product.
Inang Priscilla, ikaw na lang. Sige po.
1, 2, 3. 1, 2, 3. Okay na po.
Okay, so salamat po. Yan. So, next meeting po tayo po ay mag-experiment na. So, makikihanda po ako ng inyo pong specimen. Na-discuss ko po yung sa experiment. Discuss ko na po. Hello.
Mami, yung nasa Gcash niyo po.
Ano po?
Yung nasa Gcash.
Discuss ko na yung hindi ko pa po ano po kung ano po yung mga dapat gawin sa experiment.
Bali, ang nabanggit niyo lang po ay yung mga dapat pong dalhin.
Okay, sige po. Yan. Yung mga PPE. Hello. Yung
Yes
mga
po,
PPE
ma'am.
po. Okay, sige po. Yan. So, makiki-prepare po ako ng PPE and yung specimen natin. So, kita po tayo sa next meeting. So, pwede na po kayo mag-leave.
Thank you po, ma'am.